Now let's talk about another application of combinations involving lattice paths, which are paths in a lattice. So let's first define a lattice. The integer lattice is the set of all points in the xy plane such that x and y are integers. So 0, 0, 1, 0, 2, 0, or 0, 1, 1, 1, 2, 1. Just any points that are at the intersections of grid lines. A lattice path is one of the shortest possible paths that connects 2 points on the lattice, moving only horizontally and vertically. So let's say we had the point 0, 0 and the point 3, 2. What does a lattice path look like there? A lattice path has to only go horizontally or vertically, so a lattice path could look like this, where we've gone along an east step, and then a north step, and then an east step, and a north step. Notice to get from 0, 0 over to 3, 2, we're going to have 3 east steps and 2 north steps, because we have to go over 3 units, and we have to go up 2 units. Okay, so we've defined a set of objects. Now let's count them. How many lattice paths are there from 0, 0 to a comma b for some point a, b in the lattice? Again, it's always useful to draw out some examples. So if we want to go from 0, 0 up to 3, 2, we could take 2 north steps and then 3 east steps. It's probably good to be organized about how we draw all the paths so that we don't miss any. So here are 4 lattice paths that go from 0, 0 up to 3, 2 that start off with a north step. The first one goes north, north, east, east, east. The second one goes north, east, north, east, east. The third one goes north, east, east, northeast. And the fourth one goes north, east, 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 north. And if you're careful about making sure that you have every single lattice path, you'll see here that we've drawn 10 of them. And each of these lattice paths goes from 0, 0 up to 3, 2. Again, we want to put this into a framework that relates to combinations. Let me write down the exact steps that each of these lattice paths take. We have a path that goes north, north, east, 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 northeast, northeast, east, etc. And if you look carefully, you can see that the only difference between these lattice paths is where the north steps and where the east steps appear. There's always 2 north steps and 3 east steps. Here's 2 north steps, and here's 3 east steps. Here's 2 north steps, here's 3 east steps. So what we've learned is that a lattice path from 0, 0 to AB corresponds to a sequence of A east steps and B north steps with a choice of which positions the E's are located. There are A plus B total positions, and A of them are where the E's are E's. This means if we're computing the number of lattice paths from 0, 0 to AB, we're choosing the positions of the A plus B total letters to be E's, which is counted in A plus B choose A ways. In this example above, we have from 0, 0 to 3, 2, so the total number of paths should be 3 plus 2 choose 3. This is 5 choose 3, which is again equal to 10. Let's use this to do an example. How many lattice paths from 0, 0 to 11, 7 pass through the point 3, 2? Let's draw a picture. We're starting off at 0, 0, and we're going up to 11, 7. And we need to pass through the point 3, 2. If this question had been how many lattice paths go from 0, 0 to 11, 7, we would know that the answer is 11 plus 7 choose 11. And those paths can avoid 3, 2. But if we make the restriction that the paths have to go through 3, 2 on their way to 11, 7, you'll notice that this picture looks like 2 smaller rectangles that we have lattice paths in. This first rectangle goes from 0, 0 up to 3, 2. That has 3 horizontal steps, 2 vertical steps, of which we need to choose 3 of them to be horizontal. And in this rectangle, we start off with x-coordinate 3, and we go up to x-coordinate 11. So there are 8 horizontal units. And we start off with y-coordinate 2, and we go up to y-coordinate 7. So there are 5 vertical units. And so the number of paths from 3, 2 up to 11, 7 is the same as the number of paths from 0, 0 up to 8, 5, which is 8 plus 5, choose 8. And so if we want to count the number of lattice paths from 0, 0 to 11, 7 that pass through 3, 2, those correspond to pairs of lattice paths, one that goes from 0, 0 to 3, 2, and one that goes from 3, 2 to 11, 7. There are 5, choose 3, different lattice paths that go from 0, 0 to 3, 2, and there are 13, choose 8 lattice paths that go from 3, 2 up to 11, 7, for a total of 5, choose 3, times 13, choose 8, such lattice paths.